Hi everyone, I'm Kash from Section 9 of Digital Systems, and I'm going to explain about 2.2 BCD counter and 2.3 BCD decoder. So for BCD counter, first of all, we have to click new and create a new block diagram from here. And once the block diagram is here, we have to open the symbol tool and add an LPM counter, which is this. So for the LPM counter, there will be 4 bits. And next. So once the LPM counter is created, just plug in. And after the LPM counter, we just add and put and input from here. I'm looking for better view. So wire up the LPM counter and name the input as G clock. So once that's input, just extend the layer and rename it. Rename it as Q0. Okay, and that's all for the BCD counter. So basically, BCD counter plays the roles in as a counter. The BCD counter comes in binary decimal, and the functionality is similar to a normal counter. And next, we will create a BCD decoder using the using the BCD counter we have created. So a BCD decoder usually have inputs, and there will be multiple outputs. Basically, it decodes the input into output. The decoder we are going to use is a 7442 BCD decoder, which has 10 outputs and accepts a value in the range of 0 till 9. The output is active low, and the value greater than 9 causes all outputs to be high. So, for the BCD decoder, let's start by looking for the decoder in the symbol tool. The symbol tool will type as 7442, and this is the 7442 BCD decoder that we are going to use. And just place it over here. And once the BCD decoder is placed, put input from here to lamp. Let's basically put from here, here, and here. Okay, so once that's deployed, rename them as Q0, Q1, Q2, and finally Q3. So that's for the input, and for the output, we will rename them as, well, for the output, we don't have to rename them. And that's all for the BCD decoder. So this schematic diagram shows 2.2, which is the BCD counter, and 2.3, which is the BCD decoder. Thank you.
Hi, I am Wei Heng. For Mapper 2.4, here is a schematic diagram. Set it as temporary top level entity. After that, compile it. After the compilation, create a symbol file for Mapper. For 2.5, stimulating the circuit. Here is a schematic diagram of complete circuit so far. Set it as top level entity. After that, compile it. After the compilation, create a new waveform file. Set the G clock to 14 nanoseconds. After that, run functional stimulation. Here is the result of waveform. After that, copy night partial BDF and open a new file called night final BDF. Only modify the night final BDF and keep night partial BDF as fallback schematic when there is something went wrong when adding the modular setter. That's all for my part. Thank you.
Hi, I'm Kaiwei. So my part is 2.6 prescaler and 2.7 programming the CPLD. In 2.6, we create a prescaler module that slows the clock from 50 MHz to exactly 1 Hz. First, we create a Verilog file and enter the code that provided by the construction manual and compile it. And this is the compilation report. Then we save it as a file name called prescaler.bsf that looks like this. Then we put the prescaler module into our top level schematic diagram, and now our schematic diagram looks like this. Now we step into our last part, which is 2.7. We start programming our CPLD. First, we assign our device into EPM240T100C5, which according to the construction manual. Now we want to set the pin. First, we set the pin 64 into our input G clock. Then we set the pin 74, 76, 78, 82, 84, and 86 into our output, which is A, B, C, D, E, F, respectively. Then all the assigned pins appear in our schematic. Next, we connect all the LEDs and resistors like shown in the manual, and now this is our connection. Then, we program everything we did until now into our CPLD using USB Blaster, and let's look at the result. Giving the power supply, the LED shows an interesting pattern. We can observe that one LED being turned off orderly each second, and constantly from right to left, and from left to right. So this is our milestone 2. Thanks for watching.